In this lecture, we'll introduce a lose condition for when our player runs out of time. I think the first half of this lecture will actually go by pretty quickly. We just need to actually create some sort of time float and then just display it on our UI canvas, constantly getting it ticking down based on time.delta time. Let's go ahead and set this text up on our UI canvas. I am realizing on our score text inside of our UI canvas, I don't think I ever actually aligned it to the right. Yep, there we go. So on our score text, scrolling down to alignment, let's just make sure that these numbers here are constantly aligned to the right. Let's go ahead and duplicate this entire text, and then we'll call this one our time text, and let's align this one to the left and make sure it's actually properly aligned all the way and anchored to the very top left of our canvas. So click this here, holding Alt, and anchor it to the very top left. We can also add some placeholder text for now. Let's do something like 0.0 so we can always display time in this format. Nice, with that set up, let's go create a new script that we can actually manage all of our time. So scripts will pop into managers, and let's create a new model behavior script. But I'm going to actually just call mine game manager. It might actually be a good place later on if we want to set up some functionality for doing things like restarting our level, for example. Inside of our hierarchy, we definitely could just create a new game object and attach this game manager to it. But for the sake of keeping our hierarchy clean, let's actually just rename our score manager game object to managers. And then on this manager's game object, we can have both our score manager and our game manager. Let's go ahead and open that up in VS Code. Well, inside here, let's just go ahead and create some sort of starting time, tick it down based on time.delta time, and display it on the UI canvas. So we're going to need a few different things, but we can just start by getting that TMP text asset, which will import the TM Pro namespace, and we can just call that our time text with a lowercase t. I'd also like to have another serialized field that we can modify for a float, just so that way, from a game design perspective, we can choose the starting time for our game. So let's just call this start time. And for testing purposes, let's actually just set that to something really low for now, just while we're testing, so something like 5 seconds. I think something more reasonable like 30 or even upwards of 60 seconds might make a little bit more sense once we're actually balancing our game. So let's create another float called time left, and inside of start, we can actually just go ahead and set time left equal to start time. That way, this is actually what we're incrementing down or up when we hit checkpoints a little bit later on. Inside of an update function, let's go ahead and just decrease our time left based on time.delta time. So minus equals time.delta time. And then let's just display this float time left to our time text string. So how do we do that? So we just say time text.text is equal to time left dot to string. All right, let's go pop back into Unity and see if that works. We can just assign our time text field, and let's hit play and see if that works. Okay, cool. Well, we are working as intended, except we have an issue where we're not actually displaying the right decimal place. I think this is really messy. You could actually even do something like time text, clicking this, and then just making sure it's never actually wrapping around. So you can go to the overflow property and just change this to not overflow, text wrapping mode, and just change this to no wrap. I think this does actually look a lot better, but I do think it's a bit messy for the sake of our game. Well, you can actually just pass through one optional overload in our game manager class in this toString method and make sure that it's always only displaying a maximum of 1 decimal place. You can always see what types of overloads you can put in inside of VS Code if you hover over the method. If you hover over toString, you can see that it has 3 different optional overloads. One way to see those overloads inside of VS Code is to click your cursor inside of the parentheses, and then I believe it's Control-Shift-Space. There we go. And then it'll pop up all the different ways that we can actually input this method. With that popped up, you can actually just use the down and the arrow keys to see all of the different optional overloads. The one that we actually want to use in this case is this string format. Now, you might actually have to look up online at the Microsoft documents for how to actually pass through this format to get what you'd like. There's a bunch of different ways you can format your strings, but the one that we'd like to use is passing through the string reference F1. This will make sure it's always only displaying 1 decimal place. So if you wanted to display 3 decimal places, for example, you could change this to something like F3. But for our case, I think F1 will do. Let's go see if that's working properly back in Unity. And there we go. Press play, and you can see we always only ever have 1 decimal place. Now, I think it would be cool that if when we actually hit the 0-second mark and we reach some sort of game over, if we go into some sort of slow-mo mode and then actually display the game over text on the middle of the screen. Well, we can do that by modifying the time scale property. But before we hop back into our game manager class, let's just go ahead and create that game over text. So let's actually just duplicate one of these texts here. We can call this our game over text. And then in the very top, let's just go ahead and center this in the very middle of our canvas. Now we're never actually changing this text, so we just want it to display game over. We can go ahead and make sure that's always aligned in the center. I think aligning it center from left to right and from top to bottom makes sense. And we just want to ramp this text way up to something like 250-ish or so. You can pick whatever text you'd like. I'm just going to use this Banger's SDF font. I think that looks cool. And then just to jazz it up one step further, I'm going to make it also italic and then click this little SC button that stands for small caps. I think that looks pretty snazzy for some basic game over text. Let's go ahead and make our game over text inactive completely in our hierarchy by default, and then we can actually just toggle this on when we need to. Nice, let's go pop back into our game manager class to set that up. We could actually just duplicate this line, and we could just create it as a TMP text asset. Well, we don't really need to actually do that. We just want the game object itself so we can use the setActive built-in method. So let's just call this our game over text. We just want to write a little if condition for when we reach 0 seconds. So let's say if time left is less than or equal to 0, then let's actually just execute some game over logic. So let's actually just keep things dry and create a void game over method. So void game over, and we just want to call game over when our time reaches 0. Inside game over for now, let's just display that text. So game over text dot set active back to true, which will just toggle the entire game object back to true in our hierarchy. And we can also get a little bit fancy and just kind of enter some sort of slow-mo mode. Well, it's actually pretty easy to do. We can actually just set the entire timescale of our game, which is always set to 1 by default, to some sort of fraction of that. So time.timescale, and I think something like 1/10 of the time or 0.1f would make sense. That's actually going to slow down everything in our game. Let's go pop back into Unity and see what that looks like. Before we hit play, let's just make sure we properly assign our game over text. Nice, let's go ahead and hit play and give that a try. Let's just see that if it hits 0 and slows everything down. And voila, cool, there we go, game over. But you can actually see, keep your eye here, you probably even saw it on the box as it flung by. Why in the world is this cart so jittery? We've slowed down everything in the game. Even though I can actually go take a look at my FPS, I'm still getting close to 200 FPS. Everything seems to be working just fine, but our obstacles are actually really jittery. Our player isn't jittery, but our obstacles are. I'd like to introduce this as somewhat of a thinking debug challenge. So have a think about this challenge. Why are our obstacles jittering so much when our time.timescale is set to 0.1f? What's the easiest and the most performant way to fix the issue? Now, this is a bit of an abstract question debug sort of challenge. I don't want to actually give you too many hints. This is the type of thing that when you're creating your own project, you might run into these types of issues, and you need to figure out and debug what's going wrong on your own. Some of you might already actually know the solution. Some of you might actually have to scratch your head for a minute and figure out what's going on. So pause the video, give it an honest effort, and when you get back, I'll show you the solution. All right, welcome back. Now, if you actually remember in your edit project settings, in the time dropdown, so here on the left, in your time dropdown, you can remember our fixed time step is 0.02 seconds. That means everything operating on fixed update, things like rigid bodies, for example, are only operating on basically 50 frames per second. But when we move our time scale to 1/10 of what it was previously, in other words, 0.1, well, now everything operating on the rigid body is actually going to be visually looking like it's moving 5 times every second, basically 1/10 of 50 FPS. So the incorrect solution might be something like decreasing this time step to something, incredibly minor. So even if you were to actually try to put something incredibly low in, not only might you actually have some issues there, granted, I don't think actually Unity would let you operate on this low of a fixed time step and it'll actually bottleneck you to 0.01. However, that's going to drastically change the performance in your game. So long story short, more often than not, the incorrect solution would be trying to minimize your fixed time step. So the subjectively correct solution would be to actually go into our prefabs. We can actually just go into all of our falling obstacles, click the base obstacle, realize that they all have rigid bodies, so they're all operating on the Unity fixed update time step, and then just change this interpolate from none to interpolate. Even though when our timescale is set to 0.1 and they're only actually updating 5 times per second, visually it will actually look much more smooth. All right, let's hit play and try this one more time and keep our eyes on the obstacles once we actually enter a lower timescale. Even though our barrel is only updating every 5 times per second on the physics system, visually it looks much more smooth. Nice, let's go ahead and finish off our game manager class. You can see it's actually still ticking down below 0 seconds. So let's actually just create a game over Boolean condition to wrap up a few different things in our game manager. Number one, we just want to make sure our time is no longer decreasing once we actually hit a game over. Number two, I think it'd be cool if we actually just disabled our player controls completely. So let's go ahead and grab a reference to our player controller. So serialized field, we can just call this player controller with a lowercase p. So player controller. Yep, there we go. Because our input and our movement is on the player controller, we can actually just in our game over method, go into our player controller dot enabled and set that equal to false. That will disable this entire component on our player. So you'll no longer be able to move once we actually hit that game over. For our time, let's just actually at the very top create a bool called game over. We can set that to false to start. And when we hit a game over, we just want to actually toggle game over to true, as you might have guessed. That way, if game over is true at the very top of our update method, we can just say if game over is true, then just go ahead and return and not actually execute any of this logic. However, let's just actually go ahead and extract this to its own method. So highlighting everything inside of update, let's just call this decrease time. All right, I think we're all set. Let's go test this out back in Unity. Let's go ahead and assign this player controller component. So we just need to drag in our player and it will assign that player controller component. Let's go ahead and hit play and give it a whirl. Once we hit 0 seconds, let's just make sure we're no longer decreasing our time. All right, cool, there we go. And if you try to actually move with WASD, you can no longer move your player when we're inside of game over. Well done on this lecture. When you're ready to move on, I'll see you there.